In lesson 12.3, we're going to solve radical equations. So first of all, we know the golden rule. If I add something to one side, I have to add it to the other, subtract. So if I do something to one side, I have to do the same thing to the other. In this example, you can see if I square the left-hand side, then I can keep them equal if I square the right-hand side. And that's going to be important when we're solving using radicals. So in this example, the very first thing we have to make sure we do is isolate the radical. So in this example, we have a plus 3, so we're going to have to subtract 3 from both sides. And then once we do that, we need to eliminate that radical, and I can do that by squaring both sides. Once I square both sides, we eliminate that radical, and then we can just solve it normally. Add 3 to both sides and divide by 2. And that's all there is to it. The main thing you need to remember is isolate radical first. That seems to be the number one step that students forget. All right, so for this one, we don't have to isolate the radical. It's already isolated. So the next step tells us we're going to square both sides. And looking at this, we say, oh, it looks like a quadratic equation. So we're going to rework it and factor. And at this point, we're going to use our zero product property. So we say x minus 2 equals 0, x plus 1 equals 0, and we're just solving for x. So we think x is equal to negative 1 or x is equal to 2. And here we have our extraneous solution of negative 1. Let's take a quick peek why that happens. So the 2 would be 2 plus 2 equals 2. Square root of 4 equals 2. That's true. Let's put in that negative 1. So negative 1 plus 2 equals negative 1. Square root of 1 equals negative 1 does not work. Anything that would unless there was a negative on the outside, which there isn't, we can't have a radical that's going to equal a negative. And that's it for this lesson. So just make sure you have those steps from the previous slide written down, and we're good to go.